let's continue the discussion that we are having. So what is happening over here? If we consider that we had uniform acceleration, that the initial velocity actually increased to final velocity under a constant gradient, then we get this trapezium. So uh, within a time of t, this is our t time. I can actually name this as time. This is the total amount of distance that was covered. So this is the trapezium that we have. The idea of average velocity is that average velocity is given by total displacement divided by total time. Because I'm using average velocity, I'm saying displacement. If I say average speed, this would be distance over time. In this case, this was a straight line motion, so distance and displacement are exactly equal because we are not going in opposite direction, we're not changing direction. So one way to find out the average speed, the idea of average speed is that if the object moved with a constant speed, if it covers the exact same area. So if you are trying to find out the average speed of this scenario, that might as well be exactly at the midpoint, because have a look what is happening. If I draw a perfectly halfway point over here, actually my drawing over here, this line was not perfectly straight line. If it was, then this should actually go through this point. So if average velocity is drawn over here, the total amount of distance covered would be this rectangle. Let me just shade it in a different manner. So the red shaded part would be the distance covered. What you should see, that the area of this triangle and the area of this triangle should be perfectly equal. So the area of this trapezium and the area of this rectangle are exactly equal. That's why in the case of uniform velocity, uniform acceleration, my bad, in the case of uniform acceleration, we can write average velocity can be given as the numerical sum of the initial velocity and final velocity, because the total distance covered is actually same. The area under the trapezium, then the area under the triangle, area under the rectangle would be exactly equal. So that's what gives us this expression, that for the case of constant acceleration, average velocity can be expressed by this thing. The rest of the part is pretty simple. If we're trying to find out the distance covered, distance can be written as average velocity is equals to E plus V divided by 2, and which can be also written as total distance covered divided by time. And if I now equate this to expression, S over T equals to U plus B divided by 2, so which ultimately gives you S equals to U plus V divided by 2 multiplied by T. This is our second equation of motion that we have. So that's another part. And then we're going to go try to find out the third expression. The third expression is actually very simple. What we're going to do is we're going to try to express the S while replacing the value of T over here. So we're going to use this second expression and replace the T. To replace the T, let's take the expression of acceleration. Have a look. Acceleration was expressed as A equals to V minus U divided by T, which can be written as time can be expressed as V minus U divided by acceleration. I just changed their places. And I'm going to replace this T expression over here. So from number 2, we get S can be also rewritten as U plus V divided by 2. This was originally there, multiplied by the value of T, that is V minus U divided by A. What is interesting that if we now cross multiply, I can write twice AS. Should I cross multiply this right now? Acha, might as well do that. Twice AS equals to V plus U multiplied by V minus U, which gives you twice AS equals to V square minus U square, ultimately leading to V square equals to U square plus twice AS. This works as our fourth equation. This is our equation number 4. Where did number 3 go? Number 3 is actually lost in the translation a bit. I mean, it should be, I could have done this earlier, but I actually misplaced it. Number 3 is actually very simple. We're going to once again use equation number 2 and replace the value of V from equation number 1. So have a look what I'm doing. S equals to U plus V divided by 2 multiplied by T. This was our second equation. If I replace the value of V over here, what you can write U plus AT divided by 2 multiplied by T. So I'm just replacing the value of V over here. That can be written as twice U plus AT divided by 2 multiplied by T. So if I just divide these two on under the both of this expression, 2U by 2 plus AT by 2 multiplied by t. 2 and 2 crosses out on this side, so ultimately we get, and if I multiply the t on both sides, both of this expression, no, not both sides, I mean, if I just break down the t as multiplication, I can write u into t plus, I'm taking the denominator as a half over here, plus half at squared. So that's what gives me this expression, ut is equals to ut plus half at squared. Now, these are the four different expressions that we can have for equations of motion. This expression can also be expressed in a ut graph. This is easy to do. I'm gonna show you the graphical representation of equation number 3 as well. This is an important bit for you to understand. Take a look. If we try to draw the graph of, once again, speed versus time of the object. Let's say this was our initial speed, u, and let's say this was our final speed, maybe over here, v. So this is the curve that the object covered. So over a time of t. Now, what we want is to find out the total area of this whole thing to find the total distance. So might as well do that. But you can see that we have two parallel sides over here. So if I try to find out the total area, this thing can be done in a very simple way. Finding out this total area can be done by means of finding out the area of the rectangle first. Let's say I'm going to go for to calculate the area of this rectangle first. And then I'm going to try to calculate the area of the blue triangle afterwards. So I'm going to use these two parts to find out the total area of the trapezium. Taisir, I'm going to go by with what I'm doing right now. I'll explain this to you after a while. So this is the two expressions. So the area of the red triangle is very simple. We have a vertical side u, we have a horizontal side t. So the area of this red triangle can be very easily written as ut. What about this part? What would be the area of this thing? I mean, how can we go by this much? Now try to understand. This additional part that we have over here, that you can see, this is the part that we are trying to find out. This is the area of that area of the triangle is what we're trying to find out. Area of a triangle is given by half into base into height. So half is a constant. The one of the side of this side is t. So I'm going to write this as t. So what about this side? So this side has a length of t because this is the x-axis. So what would be the value of this much? How much is this? Now you should remember that this part is exactly v minus u. This part is actually v minus u. Might as well erase this v. This part is actually v minus u because this peak value is v, this starting value over here is u. So if you do the subtraction of v minus u, you get this part. And from our first equation, you should remember that we derived v equals to u plus at. So v minus u should be given by at. So I can write this part as at. So this vertical side is given by at. So if I'm trying to find out the area of this triangle, that is be half into time, one of the side. There's a degree over here, multiply by 80. This is the third, this is the other perpendicular side. Together you get half 80 squared. So the total area of the triangle can be shown as the sum of ut plus half 80 squared. So that's how we can also get s equals to ut plus half 80 squared. This is just one way to find out the same expression only by graphical method. The reason I'm putting a bit of a emphasis on the term in finding them out graphically, because in many cases you would have to work with graphics with the graph situations for your calculations a lot. So if you know how the whole things actually work, it can actually prove to be slightly useful in many cases, maybe not in all cases, but it can prove to be useful. So these are the four different equations that we have. You don't have to precisely know or understand how this equation come into existence, or the derivation process is not a significant part of your syllabus. So you can choose to discard that part from your memory, but I highly recommend that you try to remember it. But this next part that I'm about to show you is really useful for the application of this formula. The first thing is that this topic is called equations of motion. So I'm going to write this equations of motion. And the equations that we have are four equations. Number one, v equals to u plus at. Number two, s equals to u plus v divided by 2 into t. Number three, s equals to ut plus half at squared. And number four, v square equals to u square plus twice as. What you are going to find out that these four equations practically handles with 5 different variables. If I write down the variables over here, these are v, u, a, s, and t. These are the 5 variables which are used in this expression. What is interesting that you'll find one variable is missing from all of these equations. This is the important observation to find out. Have a look. Within this expression, one variable is absolutely missing. It's not the unknown, it's the missing variable. I mean, that doesn't belong to this equation whatsoever. For the first equation, the missing variable is s. For the second variable, the missing variable is a. For the third equation, the missing variable is v. For the fourth equation, the missing variable is t. Depending upon these 4 observations, we can actually judge and choose that for what math are we going to use which equation. Let me give a very simple explanation example. Let's say there is a question that goes like this. Let's say question number, let's say a normal question. It says that a train moving at, let's say, 120 kilometers per hour decelerates to 30 kilometers per hour in half an hour. In half an hour. Number one, they're asking you find the deceleration. Let's say this is A, and then B, they're asking find the distance covered. So the way we can approach this problem, I mean, before you go for approaching this problem, what is important that you should know properly how to convert certain units which are not SI units. For example, kilometers per hour is not SI unit of speed, it is meter per second. We need to be able to convert this thing. Converting a kilometer per hour to meter per second or meter per second to kilometer per hour is actually very simple if you know how it works. So the very simple way that I always teach the students as for unit conversion can be somewhat like this. Try to understand. Speed of an object is given by distance over time. This is a very basic expression of speed, which means if you are considering unit, meter divided by second or kilometer per divided by hour, they are both some amount of measurement of some unit of speed. Now we need to convert these two. We need to convert within these two. How is that possible? So let me just show you this thing for our given math. If we are considering 120 kilometers per hour, we want to convert that into meter per second. The easiest way to do this thing is you just write it like that: 120 kilometer divided by hour. Then convert the kilometer into meter, convert the hour into second. So you write 120 into 1000 meter divided by 3600 second. So just converting the two individual things into their individual conversions. And then just use your calculator to find out the value. Have a look, how much do you get out of this? Calculator, by C. 120 into 1000 divided by 3600. কত আসছে দেখো তো? This is giving us 33.333333. So 33.33 meter per second. Same way, if you're trying to go for 30 kilometers per hour, the same drill is that 30 into 1000 divided by 3600 meter per second, which should give you 8.33 মিটার পার সেকেন্ড। এই কনভার্সন প্রসিডিউরটা বুঝা গেছে পোলাপান কি করলাম?
Yes, sir.
ইটস প্রিটি সিম্পল। আর যদি আমরা কোনো সময় মিটার পার সেকেন্ড থেকে কিলোমিটার পার আওয়ারে যেতে চাই তাহলে জাস্ট উল্টাটা করা লাগবে। উল্টাটা করা লাগবে মানে কিরকম, আমি একটা এক্সাম্পল দেখাই because we are doing this right now. Let's say if we want to convert maybe let's say 20 meter per second into kilometer per hour. If we want to do that conversion, how do we do that? Pretty simple. You just write 20 meter per second to its broken form, 20 meter divided by second, and then you want to convert this meter into kilometer and this second into hour. So how does that work? 20 multiplied by 1 by 1000 kilometer. 1 meter is 1000 part 1000th of a kilometer, so 1 by 1000. And then second, 1 second means 1 by 3600 of an hour. So that's the way I prefer to do this to avoid any type of miscalculation, which brings us to the idea 20 into 3600 divided by 1000 kilometer per hour, which gives somewhere around, I don't know how much, 20 into 36 by 10. So actually I can cut off all the zeros and get rid of the whole thing. 1 2 3 1 2 3, so 72 kilometers per hour. So that's that. এটা হচ্ছে কনভার্সন করার গ্রস প্রসেস। there is a shortcut way, আমি শর্টকাট ওয়েটা এখন দেখাবো যাতে করে তোমাদের টাইম সেভ হয়। শর্টকাট ওয়েটা হচ্ছে এরকম, খেয়াল করো। let's say I want to convert x kilometer per hour into meter per second. This is a shortcut where you have to remember something, which would mean I have to convert this thing into 1000 meter divided by 3600 second, which brings us, if I do the math, 0 0 0 0 crosses out, 10 থেকে আসবে 5, এখান থেকে আসবে হচ্ছে 18, which means this is gonna be x kilometer per hour should be equals to 5 by 18 into x meter per second. তার মানে হচ্ছে whenever I'm trying to convert kilometer per hour into meter per second, I just have to multiply the number with 5 by 18. Vice versa, if you want to convert meter per second into kilometer per hour, you have to multiply that number with 18 by 5. Now you might wonder that I'm gonna mess up these two expressions, that kilometer per hour to meter per second, for which I'm gonna multiply which. It can prove to be a bit difficult for you to remember which one to be using when. The way I usually remember this is that kilometer per hour seems like a big unit. So if I'm trying to go from kilometer per hour into meter per second, we usually multiply with a smaller fraction. And meter per second apparently is a small unit, and kilometer per hour seems to be the big unit. If you wonder what the reason I'm using the term big unit, because it is using bigger amounts of quantities. Kilometer bigger than meter, hour bigger than second. So whenever I'm converting from big into small, I use the proper fraction to make the value smaller. So 5 by 18 is the fraction. And whenever I'm trying to go for meter per second into kilometer per hour, I am using the improper fraction in reverse format, that is 18 by 5. So this can make the conversion process a bit more time saving, where you don't have to write all of these numbers and do the whole shebang of reversing them and everything. This can save you some time, especially for the MCQ questions. But then again, if you're ever confused in your exam, that আমি ভুলে গেছি বা মনে আসতেছে না যে actually কোনটা দিয়ে multiply করা লাগবে, in those cases go for the elaborate method. It might cost you 10 extra seconds, but you can be sure that your math is correct. That's really important. Anyway, so let's go by for the question that I just wrote over here. So if I just try to go for over here, let me just write the values. In this case, the initial velocity is 120 kilometers per hour, which was 33.33 meter per second. Many of you might wonder that is it important that I should write 4 SM values or 2 decimal places? My personal opinion that whenever you are working with rounded off numbers, for in between working, try to maintain as many decimal places as you are comfortable with. The more the merrier. Whenever you're writing your final answer on the dot line of your answer space, then write the final answer in 2 or 3 SF. But for the in-between working, maintaining a longer number will help you to get rid of approximation errors. Approximation error means that the error that we do whenever we add one or not add one, depending upon whether the last number that we whether the numbers that we discard, the first one is bigger than 5 or bigger than or equals to 5 or not. So maintaining a long number can help you avoid approximation error. So I'm using 2 decimal places over here, which should work for me, I hope. And v equals to over here is 30 kilometers per hour, which is actually 8.33 meter per second. So I'm going to keep these two things right over here. Now for the first question, they are asking us to find the acceleration. So in option choice A, the unknown is what is the acceleration. Have a look. The question has already also given us the time, and you can see that the time was not given in some numerical value. It was given in words. Sometimes this can happen. Sometimes the question can give you some important mathematical expression in words. For example, very common, an object starting from rest does blah 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 blah. Whenever they use this word starting from rest, this immediately implies that the initial velocity was 0. So you got to put that in the place. Whenever the question says that an object starting with some velocity comes to rest, that word rest means the velocity was 0. So sometimes this can happen. And one other problematic expression of fraction can be 1/2. I mean, let's say if I say that what is 1/2 of 8? What is your answer?
Four.
No one's gonna say 12.
Sorry, 1/2.
Yeah.
No, sir, it's 4, I think.
Okay. If you're sure it's 4, I really appreciate that, because it is actually 4. 1/2 means half. 1/2 does not mean 1.5. So don't mess with that. It's very simple. If you think in other terms, for example, 1/3, 1/4. Similarly, 1/2 is the same thing. 2/3 is 2/3. 1/2 means 1/2. So what is 1/2 of 8? That is 4. So don't mess up the expression like that. So in this case, we have the time given over here as well. So if I take the time, t equals to half an hour. Half an hour is 0.5 hour, which is actually 1800 seconds. I might as well directly write this 1800 seconds. So now comes the question. In option choice A, they're asking us that find the deceleration. So acceleration equals to what? Try to have a look. What are the variables that we have available? We have u, we have v, we have t. We're asked to find out a. So a is the unknown that we want to find out. Which variable is not a part of these 4 things? Among the 5 variables that we've seen, which is not included? I mean, doesn't even exist within this expression. That would be S, displacement. So now we want to go for the equation where A was missing, S was missing, which is equation number 1. This, in my opinion, is the easier way to go to find out which equation is applicable. That's how I actually did my course when I was in class 9 or 10, and helped me a lot. But if you can find out the equation naturally within your head, well, no problem there. Do your stuff and it's all good. So acceleration over here can be found out by the expression a is equals to, we can go for the first equation. So this should be, actually find out the acceleration actually can be found out by the formula as well. 33.33 minus 8.33 divided by 1800. It's going to be a pretty small number. 30 minus 8 is 25. 25 divided by 1800. 25 divided by 1800. I get 0.138888. 0.1, sorry, 0.00. There's another 0 I'm missing out. 0.013888 meter per second square. So I'm writing this number just so that I can carry out this value for further calculation if required. But if I'm willing to write this answer just by as is, I might also choose the final answer to write as approximated to 0.0139 meter per second square. That's my 3SF answer. If you want to write it into 2SF, you can also choose to write 0.014. That's also okay, equally acceptable. If you want to go for the B option, find the distance covered. So
Sir,
yes,
I didn't get it why we chose the first equation to do the sum.
we are trying to figure out that to find out the expression of A, what is the missing variable from the scene? Missing variable means not the unknown. Missing variable means the variable that is not included, not to be included within the equation. So we had the value of U, we had the value of V, we have the value of T, and we are trying to find out A. If you are trying to find out A, which is the unknown, that needs to belong to the equation. That needs to be within the equation, so that by placing all the other variables, you can find out the unknown, right? So you need to have an equation that is made up with these 4 variables. So what is your missing variable? Which variable is not should not be a part of this equation altogether?
S.
And among these 4 expressions, the first equation had the S variable missing. There you are.
Thank you, sir.
No problem. So that's that. And if we go for B option says that find out the distance covered. So I can go for the distance covered equation expression over here. So I'm trying to find out S equals to what? And just from the equation, just from the quotient, directly from the out of the quotient, the variables that I have available is U. Let me use green maybe. We have U, V, and T available. We are trying to find out S. So just consider these 4 variables. Let me write it over here. We have U available, V available, T available, S available. Not S available, and we want to include the S within our equation. So these are the 4 variables that should make up our expression. So what is missing? A is missing. Among the 4 expression, the missing variable is given in number 2. So might as well go for number 2 and directly find out that answer. So S is given by U plus V divided by 2 multiplied by T. So that's pretty simple. 8.33 plus 33.33 divided by 1800. No, sorry, keep the same. Divided by 2 into 1800. That basically gives you the total distance covered. Calculate করে দেখো কত আসে। I'm getting 37494 meters. I cannot write this much of a long number, so might as well prefer to convert this into standard form, which should look like 3.75 in 10 to the power 10 to the power 4 meter. So writing long numbers, whether they're in decimal expression or in full number, long numbers should be always preferred to express in standard form, which is standard form always looks like this: something point something something into 10 to the power something. That's basically the expression for standard form. This is the 3SF expression. If you want to write it into 2SF, just get rid of this location. That also works. But standard form should always have only 1 digit before the decimal point. This is the important bit. This is what we mean by standard form. Only 1 digit, I mean the unit digit before the decimal point, and everything else come later into 10 to the power some other number. That's basically it. So this is basically how we can approach these problems, and this can actually help a lot to find out a lot of different situations. Actually, I'd like to show you some problem from one of my books, which I have with me. একটু wait করো। পোলাপান আমি কয়েকটা কোশ্চেন ডিক্লেয়ার করছি, কোশ্চেনগুলো একটু লেখো, এগুলো আমি তোমাদেরকে হোমওয়ার্ক দিব। pull up your copy and stuff. আজকে ডেট দাও, আজকে হচ্ছে কয় তারিখ? 7th August. Okay, question number 1. লিখতেছো সবাই?
Yes, sir.
Question number 1. A stone is thrown vertically upwards. A stone is thrown vertically upwards with an initial velocity of 20 meters per second. Full stop. Neglecting air resistance, comma, find. Neglecting air resistance, comma, find, colon, colon means 2 dot, নিচে প্যারাগ্রাফে লিখো a, মানে বুলেট a maximum height reached, maximum height reached. B, the time taken before it reaches the ground. C, total distance covered if initial speed was doubled. Total distance covered if initial speed was doubled. Number 2. Acha, one thing to add, for all the cases where you have to use the acceleration due to gravity, the value is 10 meters per second squared. You're not going to use 9.8 because for up to even up to your O levels, the CA people prefer that you learn to use 10 for the sake of ease of calculation. But eventually, whenever you'll get up to your A levels, hoping that you still pick physics, you have to use 9.8. 9.8 or 9.81, that's the 3SF, is the more appropriate while on an accepted number. But you'll be using 10 up till your level. Number 2, a car starts from rest. A car starts from rest and is accelerated uniformly at the rate of 3 meters per second squared, at the rate of 3 meters per second squared for 10 seconds. Full stop. It then maintains a constant speed. It then maintains a constant speed for half a minute. Full stop. The brakes are then applied. and the vehicle uniformly decelerates to rest. The brakes are then applied and the vehicle uniformly decelerates to rest. In 8 seconds. Full stop.
Could you repeat this line again?
And the brakes are applied and the vehicle uniformly decelerates to rest in 8 seconds. It's better if you write all the units in their unit symbol. For example, don't write 8 seconds in spelling, but write 8s. That makes the practice better, that you learn to use the unit and also has the privilege to write less, which saves time and effort. এরপর লিখো A, find the maximum reached speed, find the maximum speed reached in kilometer per hour. Write the symbol for kilometer per hour, km, h inverse 1. Find the maximum speed in kilometer per hour. Full stop. B, sketch the VT graph. Sketch the VT graph labeling all necessary values. While doing any further calculation necessary. While doing any further calculation necessary. Full stop. C, using the graph or otherwise, using the graph or otherwise, calculate the total distance covered. লিখছো?
Sir, could you repeat the first line? The first line.
পুরো কোশ্চেনের ফার্স্ট লাইন নাকি সি নাম্বার ফার্স্ট পার্ট?
Sir, question or first line?
কোশ্চেনের ফার্স্ট লাইনটা ছিল হচ্ছে a car starts from rest and accelerates uniformly at the rate of, what did I say, 3 meter per second square, or I forgot the
Sir.
number.
3 meter per second square.
2 meter per second square.
3.
3 meter per second square for 10 seconds. 3 meter per second square for 10 seconds. পারছো?
Yes, sir.
আচ্ছা, আরেকটা কোশ্চেন লিখো, বলতেছি আমি। হুম আচ্ছা না, আরেকটা কোশ্চেন দেখো না, এই কোশ্চেন গুলো আমি তোমাদেরকে ছবি তুলে পাঠাবো। দিস ইজ ফ্রম ওয়ান অফ দ্য সাপ্লিমেন্টারি বুকস দ্যাট আই হ্যাভ। এবং এখানে এক্সারসাইজে কিছু কোশ্চেন আছে হুইচ আর রিয়েলি গুড ফর মেন্টাল এক্সারসাইজ। সো এগুলো আমি নেক্সট ক্লাসে তোমাদের সাথে ক্লাসে করাবো এবং করায় আলাপ করবো। আই গো থ্রু দ্য এক্সপ্লেনেশন অফ দিস কোশ্চেন্স সো দ্যাট ইট ক্যান মেক বেটার সেন্স উইথ অল অফ ইউর কিডস। দুটো হোমওয়ার্ক দিলাম, দুটো হোমওয়ার্ক তোমরা ট্রাই করো। আর হচ্ছে যদি ওয়ার্কশিট অ্যাভেল করতে পারো, এমসিকিউ পেপারটা ট্রাই করতে পারো। এবং যদি ফর দোজ হু হ্যাভ অ্যাভেল দ্য ওয়ার্কশিট, ইফ ইউ হ্যাভ অলসো ট্রাই আউট দ্য টাইম গ্রাফ এমসিকিউ হুইচ ইজ দিস ওয়ান। এই যে P1 ওয়ার্কশিটের প্রথমটা হচ্ছে তোমাদের এই ফার্স্ট চ্যাপ্টারের ওয়ার্কশিট। এরপরে হচ্ছে মনে হয় ইলাস্টিসিটি একটা ছোট ওয়ার্কশিট, সরি টিকার টেপের একটা ছোট ওয়ার্কশিট আছে। This is number 2 and number 3 and number 4 is the time graphs. If you have access to this paper and if you can make some time, also attempt this paper as well. You do not have access to the answer key of the MCQ paper. MCQ answer key আমি তোমাদেরকে নেক্সট ক্লাসে দিব। MCQ পুরো আনসার কিটা একটা পুরো টেবিলে দেখানো করা আছে। আমি তোমাদের দিছিলাম কি, তোমাদের গ্রুপে কি দিছিলাম? Did I provide you with the answer key? একটা পেজ দিছি শুধু, সমস্যা নাই। আমি তোমরা যদি টাইম পাও তাহলে টাইম গ্রাফে এমসিকিউটা ট্রাই অ্যাটেম্প করো, সেটা আমি নেক্সট ক্লাসে ইনশাআল্লাহ আবার দেখাই দিব। আজকে এটুকু থাক, ইনশাআল্লাহ নেক্সট ক্লাসে আবার দেখা হবে। আর ইয়া, হোপ ফর দ্য বেস্ট, অল দ্য বেস্ট। আসসালামু আলাইকুম।
ওয়ালাইকুম আসসালাম, স্যার। আল্লাহ হাফিজ।
আসসালামু আলাইকুম।